experiences. So it's about 5 minutes after the hour. Can everybody see my screen?
Yes, I can see your screen.
Okay, awesome. So everyone can see my screen. We still have a few people joining us. So let's take a couple minutes here to make sure everybody sits tight and quick. I think it's only natural that I should introduce myself. I'm Vitus DK. You can call me whichever way you prefer. I'm never offended by that. I'll only be offended if you have a question and you do not ask. So that said, we're going to be spending quite some time together to figure out this Python thing, right? So it's going to be very, very interesting. So a few things to paint out of the box. Everything is going to run through the website. If you go on the website, you can actually, obviously right now, I have to change the time because earlier we wanted to start at 7 p.m. So it has the time on there. You can click on this link. This link will join the class right here. Or you can make an appointment if you want to talk before the class or after the class. There's also a calendar. You can check out the calendar to see the class times and so on. But oops, let me go ahead and have a few people joining in. So let me admit everybody on. So again, the class calendar, you can go on there. Like I said, if you have questions, you don't feel comfortable asking in class, book an appointment, a 1-hour appointment or a 30-minute appointment. That's totally fine. One thing that I'm going to request from you is to share your email address. The reason I need that is because rather than using WhatsApp for communicating, we are going to use Google Classroom, okay? So what is Google Classroom? Google Classroom is pretty much a learning management system. In there, you can ask your questions. I'm going to share with you all the slides, all the notes, all the video recordings. It's easier for us to manage it that way. And rather than having to scroll through WhatsApp messages, you always have this available to you. So if you're wanting to review contact later on or anything, you can always go back there, grab information that you need and collaborate. The questions you ask, you can ask them directly to me or you can ask it to the entire class. But I've sent a link to our chat. You can click on that link and join the room directly. On there, you should be able to see all our content, which is broken down into the separate weeks that we're going to have. So I've broken those down, which you definitely have that in there. I'll have some assignments sent out to you, some quizzes to make sure everybody's up to speed. Okay, so what questions do we have on that? No questions. So yes, again, most of the stuff we're going to go through our website to get our content. And when you navigate to the website, you go through programs and Python. Scrolling down, you would see a description that has our learning objectives. On the next tab, there is curriculum. In that curriculum, what you can do is click on the lecture that you're interested in. In this case, we are looking at Introduction to Python, which is day 1. You will have the PowerPoint available to you. So every single day I'll have this PowerPoint updated so that you can follow directly what I'm saying in class. You also have a hard copy of this, or sorry, a soft copy of this shared in our Google Classroom. Does that sound good to everyone?
Yes.
Yep. So again, PowerPoint is out there available for you to follow, or you can simply just follow as I'm sharing this on here. Today is going to be a lot of talking on my side because again, it's an introduction, right? But tomorrow and next week, it's going to be a lot of hands-on. You'll be having a lot of fun. So the one thing I want you to take away from this class is having fun. No matter what it is, you're going to learn, you're going to have fun, and you're going to learn more while you're having fun. So that said, today again, looking at introduction, let's jump in and see what are some of the things we'll talk about. We'll talk about what code is. I know some of you did mention earlier, it's kind of a turnoff when you see you need some kind of programming experience if you're looking at a job. And we also want to say in particular, what is Python? Also, we need to define why is it important for us to code, and why do we want to choose Python as a coding language, since there's many of them. Finally, well, not finally, what the different flavors of Python and some of the tools that you use to be able to write Python code or execute it. Finally, just like any normal language, you want to talk about the anatomy of the programming language. All right. So what questions do we have in terms of the objectives, the things we have to achieve today? No questions. So forgive me, today is going to be a rough day for me because I just got back from the dentist and I feel like part of my face is swelling and the other part is normal. So hopefully, as the time goes by, the anesthetic is going to wear off. Hopefully, I don't cry in front of you guys as well. That said, let's jump in and talk about what coding is. Like I said, we will learn what coding is, why we want to code, and discuss about the anatomy of Python. But before we get started, we need to talk about computers, right? What is a computer? Computer is not necessarily the laptop or the desktop you have. Your cell phone is a computer, right? What is the purpose of your cell phone? What is the purpose of your computer? It's just to help you, right? It's a tool. It wants to do things for you. So it's just sitting out there and waiting for you to be able to give it some kind of command, some kind of instruction. But the challenge we have is we cannot speak the computer's language. We as users cannot speak the computer's language, but programmers are the ones that can speak the computer's language, and they do that in terms of ones and zeros. I don't want to scare you with all those ones and zeros and how the nitty-gritty goes in there, but I want you to look at it from the perspective that you are no longer a user. Okay, the user is the person that's punching numbers on your cell phone. Look at it from the perspective that you're the programmer. You're coming from inside and trying to solve problems for others. So again, taking an example of a car. Everybody would like to have a car. Everybody would like to drive a car. The person that's driving the car is the user. But when that car breaks down, if we need that car to do something, maybe signal left, signal right, brake and not make noises, speed up and not slow down, we need a mechanic, for instance, a technical person that knows the inner workings of the car. So normally you just drive the car, you don't know how it works. But at this point in time, we want to be able to look at it from the perspective of the mechanic, okay? So since we need to look at that, let's talk about what code is. Code is a piece of creative art. It's also a sequence of instructions. For instance, in a car, you have to give it instructions. In order for you to drive the car to move faster, you need to step on the gas. Technically, I have no idea what happens when I step on the gas. All I know is I step on the gas, the car moves forward. I have no idea what happens when I step on the brakes, but when you step on the brakes, the car slows down, okay? So that's pretty much the same thing. The users just know that, hey, I'm doing this and that works. But what we as programmers, or what you as a programmer will have to do, is to create a series of instructions that will be able to be executed to get a particular result. So code is also known as software. It's also known as a program. It's also known as an application. It's interchangeable, but there are some subtle differences. In order for us to define what code is, we need to have a big picture of what computer is made up of, per se. So everybody has an idea of what a computer is made up of. Can anyone tell me what are the main parts of a computer in a big picture perspective? You might have to unmute so I could hear you. Any takers?
Hardware, software.
Perfect. Hardware, software. That's very good. Hardware are the things that we can tangibly see and touch. Software are the things that we can see, but we cannot technically touch them, right? So I don't want to bore you with this. You might think, why the hell do we need to understand this stuff? I just want to go in and start writing the code. But it's a good idea for you to know what actually we're trying to do in the back end. I promise you, we're not here to start building computers from scratch. It's just to give you an idea of what it is that we do as programmers. So as you can see on here, the computer is, let's see if I can use my highlighter here. So the computer is made up of, let's get the black one, no, the red one. Oh, never mind, it's not gonna let me do it. Always does that to me. So yes, the computer is made up of a hardware and the software. What's the hardware made up of? The hardware is made up of input and output devices. Input devices could be your keyboard, your mouse, maybe even a microphone. But your output devices would be your screen, your speaker, and so on and so forth. Okay. But those we are not really concerned about. What we are concerned about are the inside, okay, the internal hardware, which is made up of the CPU, which you see on here, the main memory, and the secondary memory or the hard drive. You also have external memory that you can use. So what happens is the CPU, the central processing unit, is just very super fast. Okay, it doesn't have any reasoning. It's not as smart as us. Us humans are smart. We just have to figure out what instructions to give the CPU. But the CPU can have about 3 million or 3 billion instructions executed per second, which is what makes computers really super fast. So because of that speed, we have to write very concise and brief and straightforward instructions. For instance, if you need to make coffee, you have to give instructions to say, okay, grab a kettle, put some water in it, warm it up, grab a cup, pour the water in it, and so on and so forth. You have to be really mundane in the way you have these instructions. So your instructions are usually saved here in your main memory, okay? But the main memory is saving it long term. So when it says it, sorry, it saves it short term. When it says it short term, if you turn off the computer, that memory evaporates. But if you need it to be saved long term, then you have to save it on your hard drive, which is your secondary memory, okay? But this holds the information that passes on to the CPU and the CPU executes it. So when you write your program resides in the memory. The memory then feeds the information to the CPU and the CPU executes it. So at the end of the day, just like you have right now, that cell phone, that computer, that hardware, it does nothing. The CPU is just sitting in there and waiting for instructions. The instructions are stored in the memory. And the way you can send those instructions is you use your input device to be able to type in the instruction. It sends it, whether it's a message or it's a phone call or it's a calculator, it's an app for playing music, and so on and so forth. So does that make sense to everybody what exactly coding is?
Yes, sir. So if you're buying a computer, it's better for you to focus more on memory, which will store the information, or on CPU for processing.
Very good question. So the two things that really stand out, let me escape out of this. The two things that really stand out when you're buying a computer, like you said, is CPU and memory. Now you want to focus though on the fact that I don't want the whole of that thing. There you go. On the fact that the CPU again is the one that's going to be executing all the instructions. But the CPU also has the amount of space that it can use, the speed that it can go. If the CPU is running at a speed of 5, whatever the unit is, and you have a memory that is running at a speed of 100, you're limited by the speed of that CPU, right? But if you have a CPU that's running at a speed of 500, the CPU will always be there waiting for the memory. So you have to balance it out. Which one is more important to you? Is it the speed at which you're executing that, or is it the amount of executions that you can send at one point to the CPU? Does that make sense?
That's great. Thanks.
Yeah, so even though you have your memory of 100, you can have a CPU of 5 million. It's not going to do any good. You just have 1,000 people waiting in the farm to work, but the farm is so small, there's nothing for them to do. So they're just sitting around eating mangoes. But if you have 5,000 people that, or if you have a yard of 1 hectare, but you have just one person, that one person will never be able to finish clearing the entire hectare. So you have to look at the difference between your CPU and your main memory. Input and output, those are just fancy things. You can spend all your money on your screen and on your keyboard. They pretty much just do that, input and output. But sometimes you might want to expand your memory. Maybe you get a faster hard drive, a bigger hard drive, or you get external memory to add onto it. All of those things just store your program. They store your program, but in order for your program to be executed, it's the CPU that is the key. The brains, if there was ever a brain in a computer, would be the CPU, the central processing unit. Does that make sense?
Yes, it does.
Awesome, awesome. So let's carry on from there. Please, if you have any questions, interrupt me and we'll go from there. So like I promised, we're not here to learn hardware, software, but it's good to have a background information, because at the end of the day, all we are going to do is we're going to be creating pieces of art. The way I write my code will be different from the way you write your code, because there are so many ways to get to your destination. You might be going left, right, right. I might be going right, right, left, and we'll still get to that same destination. So that's why it's art. Because when they ask you to paint a man, the way you paint a man is different from the way I'll paint a man. But at the end of the day, the man is going to have a head, eyes, hands, legs, and so on. So it's a sequence of instructions that you're giving that gets stored in a memory and gets executed in the CPU. All right, let's carry on from there. So why do we need to code then? Okay, we need to code because we want to get tasks done. We want to solve problems. Most of the time, people write code because they want to solve their problems, but then they realize that it's useful for others to also be able to solve problems in this way. If I know how to create a tire for a car, I just have to make that available for everybody else. Then they don't have to go and reinvent the wheel. Okay, so you produce solutions for yourselves based on a particular problem that you encountered, and those solutions get shared and it's available for everyone. So again, coding is because computers cannot learn our language, but we are smart enough to learn ones and zeros. Because at the end of the day, when we looked at, let me go back a little bit. When you look at the CPU before, back in the days in the 60s and 70s, there used to be entire cabinets. Entire room of cabinets is what gives you the CPU. But why is that? Because it's pretty much the presence of electricity going through cables, through wires, gives you the 1, and the absence of electricity gives you the 0. So as time went by, these transistors, capacitors, and cables or wires got smaller and smaller. Guys figured out ways to make them smaller and smaller. All these Apple, Microsoft, Windows guys, that's what they did to be able to make sure that those computers that filled up entire rooms can now actually be in a cell phone. The cell phone does have exactly all of those because they figured out ways to merge millions and millions of transistors to tiny little chips. That's how we started out with Pentium, Pentium 1, Pentium 2, and so on and so forth. Now you have dual core, quad core, and so on. So their computers cannot learn our language, but we can learn how to write code, which would be translated to ones and zeros. Python is just one of the many programming languages out there. There are countless programming languages. But Python translates your code just like an interpreter. When you speak in your dialect, somebody changes it to English, or you speak in French, somebody changes it to Spanish. Python interpreter sits between what we are going to type and then translates it to ones and zeros for the computer to do it. Ones and zeros is what is known as machine language, because a machine understands presence or absence of electricity. Does that make sense to everybody?
Yeah, it does.
Awesome. So yeah, at the end of the day, that's what coding is. It's nothing more than that. Coding is just you sitting between me and your grammar, so that when I speak in English, you can explain to your grammar in the dialect that this is what this person is saying. When your grammar speaks in a dialect, you can explain it to me that grammar says you're a very handsome boy, right? Except you guys don't think that, but I don't know. Anyway, but why do we choose Python? There are many, many features that Python has that makes us prefer to choose Python. Okay, it's easy to write. When I say easy, it's literally easy to write, just like English language. Okay, it's also easy to understand, because if you see some codes out there, back in the days, assembly language, which is low-level code, and Python, which is high-level code, you can look at Python and have an understanding of what the code is trying to do. But before, when you see 10011100, you have no idea what's going on there. Okay, and when it's object-oriented, that means it relates to real-world scenarios. Just like you have a car is an object. You can say this car is of year 2020, it's of color red, it's of model coupe, and so on and so forth, brand, and all those different things. So there are countless features that Python has, okay? It's also very extensible, very portable, and scalable. You can integrate it in many places, and most importantly, it's free. Who doesn't like free stuff? It's free and open source, okay? So those are some of the reasons why we code and why we choose Python over many other programming languages. But what is Python? What exactly is Python? Is it a snake, or is it, I can tell you a lot of things about it, who discovered it and all whatnot, but that is not of the essence right now. Anyone can read up on that. But a few things that we need to point out are that Python is a language of the Python interpreter. Like I said earlier, the Python interpreter is what sits between you and the CPU, that it actually goes about the translation and interpretation of the code to make sure that it becomes machine readable. Okay, it has dynamic semantics. We'll talk more about this later on. Most other programming languages, when you want to write something in, you have to define every single thing you're writing, and it cannot change. It's static. So if you have static type, for instance, if I'm going to a bank to open an account, if this bank says once you open a savings account, you cannot change it from a savings account, that's what it's going to be. It's going to stay that way. So for instance, I go into the bank and I say I want to start saving stuff in the vault, and they'll ask me, what are you going to save? I'll say, I have some important documents that I like to save, maybe certificates and so on and so forth. And they say, okay, guess what? We're going to give you a drawer. You're going to save your certificates in a drawer. And then I come back tomorrow and I said, you know what? I'll also like to save, I found some, gold behind my yard when I was digging up. I want to start saving my gold in there. They'll tell you, no, you cannot change this size because it's static. But with Python, it's dynamic. At that point in time, you can say, you know what? Rather than giving you this drawer, we're going to give you this room. You can go ahead and take the room, the entire room, and save your stuff in there. So that's what it means by Python is dynamic. Okay, for some people, it might be good. For some, it might be a problem. OOP in here stands for object-oriented programming. Like I pointed out earlier, Python relates to real-world scenarios, objects, okay? Everything is an object in the world of Python. And in that way, objects have two things. Objects have attributes, what they have, and they have methods, what they can do. Okay, so what you have are attributes. What you can do are the methods. For instance, a car has attributes. A car has a color, a year, all those information. The car can also do stuff. The car can drive forward, it can reverse, you can honk the horn, and so on and so forth. So those are some of the things that Python has that makes it different. Now, it's a general purpose language and also high level. When you say high level, it means you don't really need to write your code in machine friendly way, because there's low level code, which is machine code. And then there is also middle level, and which is assembly code. You know, back in the days, they had to write assembly language. But high level, you just write it in regular English or whichever word you want to use. And then it gets broken down using the interpreter to the low level language. Okay, it might be slower compared to machine language, because machine language does not need someone to translate, but it's a lot easier for humans to write, read, and do. Okay, so there are a lot of applications, as I listed earlier, in in the in the world that you actually use Python for. You know, the big one here is data analysis, as you can see, whether it's data science or it's databases or it's data analytics and so on and so forth, and also web development. Okay, DevOps is something that's growing very much. Systems admins, whether it's Linux systems or it's Microsoft, whichever system it is. And for automation, okay, it could be home automation, it could be whichever type of automation. And you can use it to also scrape websites, be able to go out there and fetch information. For instance, machine learning, which is a superset of artificial intelligence, which is something that everyone nowadays is talking about, ChatGPT and so on and so forth, for educational purposes and so on and so forth. You know, there are bunch of uses for Python that it's very powerful for you to have this on your resume. You stand out, okay? And not just when you talk about Python. Now you understand the semantics, what's going on behind the scenes, the background of what Python is. Based on that, you have a better understanding. You can explain yourself, and you can have a better understanding of what your code is trying to do and what it cannot do. Does that make sense to everyone? I know a lot of talking, a lot of talking. What questions do you have? Please go ahead and let me know. No questions, and if any questions come up, do well to raise your hand and I'll definitely address your questions. So that's it. We've been able to answer a few questions so far. Let's see what else we can answer. Python has many distributions. Like we said, you know, Python is a programming language. When we say a distribution, does anybody know what a distribution is, for instance? I know if there are some Linux admins in here, you probably know what a distro is, right? The short form for distribution is a distro. You might need to unmute if you want to speak up, and there's no wrong answer. If you have an idea, vague idea, then we can talk about it.
Should it be like flavors of different things?
Definitely, that's a flavor, right? So let's take, for instance, with Windows. Many people are familiar with Windows, right? Windows systems, when you go and buy a computer, you have to decide, you know, or well, normally you don't have to decide. They'll tell you this computer uses Windows 10, Windows 11. You know, if it was back in the days, maybe Windows 95 when I started using computers, Windows NT, Windows 2000, and so on and so forth. Those are different versions. When Microsoft creates their computers, right, they create their computers with an operating system. So the computer has a platform. A platform, think about a stage. When you go on stage, that stage has a platform. On that stage, you might have Petit Pay come to the stage and sing and go. You have Ted Boulay come to the stage, sing and go. Rihanna will come to the stage, sing and go. Those are all people coming to the stage. It's a platform. So operating system is a platform. With Windows, you have With Windows, you have with PCs, you have Windows operating system, right? With Macs, you have the Mac operating system. Linux also has its operating systems. But when you have a company like Linux, which has open source depending on Unix, they might decide that they want certain things to be packaged together with their operating system when they ship it out. So think about Brasseries du Cameroon. Maybe you have a certain brewery. In that brewery, they're going to decide that we're going to package sweet drinks and send this one out as Gino cocktail. Package these drinks and send it out as Beaufort. Package these drinks and send it out as 3 Export. Those are different distributions. Those are different flavors, like you said. With Python, there's a standard version, which is C Python. It's built on the C language, okay? But you also have different distributions. If you like to be using Python for commercial reasons and to do scientific stuff, maybe data science or analytics and so on, then you probably want to go and use the Anaconda Python distribution. If you're going to use it for data scientists or enterprise stuff, then the active Python distribution will work for you, because all of these other distributions depend on C Python, okay? So when we want to install Python, we need to know what distribution we are going to install on our computer. If you're looking at a Mac operating system, Mac operating system comes with Python pre-installed. That would be the C Python, which is the standard version. Linux operating system also comes with the standard Python version installed. But for Windows, Windows does not come with standard version installed. So we'll need to get some kind of version of Python to install on there to utilize it. Does this make sense? Good, good, good. Okay, good for the thumbs up. Yes, question. Go ahead with your question. Yes, Nigel, you can go ahead with your question. You have to unmute. There you go.
Yeah, my question is which one, which of which shall I say flavor or distribution of Python is the most popular one, like the one that is mostly used by other companies? You know how, for example, we can say Toyota is the most, when it comes to cars, we can say Toyota is the most uh used cars all over the world kind of thing. I was just thinking like, okay, flavor wise, which one is the most popular? Which flavor is the most popularly used? I was just curious.
Very, very good question. Which of these flavors is popular? Now, I will have to give you the $1,000,000 answer on that one. It depends. Why do I say that? It depends on which environment you find yourself in, okay? If you're in a situation or a company that's working on Microsoft Windows, then you probably find WinPython. That's going to be popular. If it's a company that works on maybe mobile applications and thinking about portable systems, then they'll probably be using Python Portable, which is self-contained for mobile, self-contained system per se. But like I said, all of these flavors are derived from C Python, except say you are working in a company that uses Java to build everything. They use the Java ecosystem for all their software and so on and so forth. So they depend on the Java virtual machine. So they'll definitely be using JPython or Jython. If it's Ion, if it's .NET ecosystem, which is also another Microsoft stuff, then Ion Python. But Anaconda Python is probably the most popular. Why I say that is because it comes pre-packaged with a lot of math, science, data science, and statistics stuff. And as you can see previously, let me go back a couple slides, permit me. Data analytics is the most popular area where Python is being used. So in data analytics, most people are going to be using Anaconda. So that again takes a bunch of that. But if it's for educational purposes, maybe less people are using the other flavors of Python. But C Python is the standard. Anaconda Python will probably be the most popular. Does that answer your question?
Yes, it does. And I had a follow-up question. My follow-up is, which one are we going to be learning in this class? That's my follow-up question.
Excellent, excellent. So all of them have the same syntax. Let me just make that clear. All of them have the same syntax. It just depends on which runtime environment you're going to be using. So at the end of the day, when you look at distributions again, whether you're going to be drinking whichever type of drink, you will still be using the same cup or the same glass or the same what do you call it, bottle. Okay, so C Python is just the distribution that everything resides on. But when we want to install Python, if you're going to be using Windows or Mac or Linux, all the Python that we're going to write is going to be the same. It's going to be the same language, but the person that's going to be translating it behind the scenes is going to be different. Okay, does that make sense?
Yes, it does. Thank you.
Awesome, awesome. You're welcome. I had another hand up. I think I might have missed it. Does anyone have another question? All right, I must. Yes, Aaron, please go ahead.
Yeah, are we supposed to know what distribution we are using?
Very good question. We are really not supposed to know what distribution we are using, but what I'll do is I'll give you guys the link to read up more on this at your leisure. You don't really need to know it, but it's something that's useful to help you open your eyes to, you know, what exactly it is that we're learning in Python. And in case you go to an interview, or if you see someone has a post out there for a job and they say, hey, they need you to know this and that and that. Okay, it gives you an idea to know that, okay, I don't know C Python, or I have never used Jython, because Jython is a Java version of Python, but I've used C Python in everything that I know. Okay, so here is the link. I'm going to share it with you guys in the chat. So let me post that in there. You can go directly to it. It's from InfoWorld. It actually breaks down all these different flavors of Python. Okay, so as you can see, C Python, you can read more on the use cases, the limitations, and Anaconda Python, the use cases, limitations, and so on and so forth. Okay, so there's a ton of them. We don't need to go through all of them, but if you need to read up more on that, it gives you an idea what exactly is a distribution and how Anaconda Python, the separate use cases, as you can see, is for math, statistics, engineering, which is the most popular of all the uses of Python. Does that make sense to everyone?
Yep, thanks.
You are welcome. So
quick question. So
yes, go for it.
On that last slide, yes. The Win Python for Windows users, for example, I will be using Windows. Yep. If I install that, will I have the options to cherry pick, like, yes, I'm picking Win Python, but I want Anaconda version, or it comes pre-packaged with all of that? I'm not sure.
Excellent question. No, I love that question. So when you want to install Python, which was going to be the next thing we'll talk about, obviously, let me go back to our old slide. There you go. So when you want to install Python, right, it's up to you now what version you want to install. If I go in and search on python.org, obviously, they're going to give me the standard version of Python. Okay, so if I go to python.org and I want to download, it's going to tell me, give me just the standard version of Python. If I need to get the Anaconda version, I need to go to Anaconda, and then you see Anaconda products distribution. This would be the Anaconda version. If I want WinPython, I'll have to go to WinPython and so on. So it's up to you to decide whichever one you want. But like I said, in here, you can see the use cases. Anaconda, again, is pretty popular because it comes with all of these SciPy, NumPy, Number, all those libraries, which we'll talk about libraries and packages shortly. So depending on what thing you want to use Python for, because Python is used for so many different things. If you want to use it for visualization, then you have to use the one that has visualization packages that you can leverage. If you want to use it for Windows products, then you have to go look for WinPython. If not, just get your standard C Python. With that standard C Python, you can add your libraries individually. Does that make sense?
Yes, I'm happy to have that flexibility.
Excellent. So we know, for instance, in Africa, we have different flavors of jollof rice, but the base is rice. The rice must be there. So C Python is just like the rice. If you decide that you want to cook Senegalese jollof rice, then you have to figure out what different ingredients that you need to use to be able to get Senegalese jollof rice, which might be the Anaconda Python. If you decide that you want to cook Nigerian jollof rice, then you find all the ingredients that you need to be able to get that. Or maybe just go ahead and buy the Nigerian jollof rice as it is. Or if you want a mixture of both of them, then you can go ahead and get all the spices that you need to be able to make that. Does that make sense? Awesome, awesome. Good, good, good. I love those questions. Keep them coming and do not hesitate. Oops, that's not where I want to be. Do not hesitate to ask any questions when it comes up. So we've talked about those different distributions. The reason I wanted to talk about distributions is because I want us to understand that before we get to installing. So now some people might know a little bit about cloud programming. Again, cloud programming or cloud computing rather. Cloud computing is just having services that reside on someone else's computer and utilizing them over the internet, right? So we can install Python on our local machine. You can install it on your laptop, regardless of what operating system it is, because let's go back again, which I forgot to mention. Python is, oh, I don't have it on there. That's horrible. Well, I did have to mention Python is cross-platform, which means you can write the code on any platform and utilize it on any platform. Platform, again, has to do with the operating system. Okay, so if you want to install Python on Linux or Mac operating system, it already comes pre-installed. It's up to you now what version you want it to be. You can upgrade your version or downgrade and so on. The two primary versions of Python are Python 2 and Python 3. Python 2 has been discontinued. Python 2 had its end of life. I think that was in 2018. 2018. Don't quote me anyway. I might be wrong in that. But going forward, nobody's writing any code in Python 2 anymore. So maybe you might go into a job that hires you and they said, hey, we have someone that wrote a Python code. Everything was written in Python 2. Can you switch it over for us to Python 3? That's fine. All you have to do is just remember all the new additions and new features that were added to Python 3. So when installing, make sure you're installing Python 3. That's the version that you want. Now the distribution is up to you, okay? If you're on the cloud, you might be using what is known as an SDK. Does anybody know what an SDK is?
It's software development kit.
That's correct, a software development kit. So with this distribution, you then have a software development kit that is produced. A software development kit is just a set of tools. Think about it like a toolbox, okay? Back in the days when I started learning programming, you have to first buy the book. In the book, there's a CD in the book. The CD has the software development kit, because not everybody is the one developing software. So if you want to learn Java, you buy the Java book, open in the back. Hopefully nobody has stolen the CD. You get the CD and put it in your computer, install it and all whatnot. Nobody's doing that anymore. All you need to do now is go to the website, click on the link, download your distribution, your software SDK is created for you in the back. So for each of these cloud systems that are cloud providers, AWS for Amazon, Azure for Microsoft, GCP, Google Cloud Computing, or Google Cloud Platform, they all have their different flavors of SDK that works just fine with their architecture, okay? So when you go on there, when you see SDK, don't get confused, like what the hell is this? They're not talking about MeDK, they're talking about SDK. So it's just a software development kit, a bunch of tools that will help you write code in Python. Does that make sense? Good, good, good. So again, installing it locally. To install Python locally, it's pretty straightforward. Like I pointed out, you can go to python.org and download it, whichever version is useful for you, or you can use it on the cloud. Personally, if you're using a Chromebook, you would have a difficult time trying to install it, and I don't want us to waste too much time with that setup. I encourage you to use either Anaconda instead of downloading it. If you don't have a Windows, Mac, or Linux computer, you can just code it in the cloud. All you need to do is provide a username and password. Once you sign up, which is free. Once you sign up, provide a username and password, you should be good to go. And I probably forgot my login, so that's not a big deal. But there are many other ways in which you can use Python on the cloud. You can use repo.it, which we'll talk about in a little bit. Again, this also uses Python built in, whichever distribution. I can't remember if this is C Python, but there's so many of them. There's Code Anywhere and so on and so forth. I'll give you a list of all of them in the notes, but just to let you know, there are many, many options out there for you if you want to code in Python, but you don't want to have the headache of installing it on your machine. Does that sound good to everyone? So again, a few other ones, you have Python Anywhere. From there, you can host one and code Python in the cloud. There's also Code Anywhere. With Code Anywhere, you get to choose what programming language you want to use and so on and so forth, okay? So there are many, many options that you can use. But if you are using a Mac operating system or a Linux operating system like myself, you can go ahead and open your terminal. Once you open your terminal, to check what version of Python you have to type in Python. Sorry, let me make this bigger so everybody can see. Okay. So you have to type in Python 3, which is for version 3, like I pointed out. Python 3, a first dash and a second dash, those are 2 dashes, and then you type in version. That is going to tell you what version of Python you're running. This is currently running Python version 3.9.6. Okay, so that's how you would know if you're running on a Mac. If you're on Windows computer, what you need to do to check if you have Python installed or what version you have, you just type in Python -- version. That's what you need to type in Windows. So check that out. And you should be able to get that. Now, for those who are on a Mac, how do you open a terminal on a Mac? Let me close this and start from afresh. So to open a terminal on your Mac, what you need to do is go to Applications. When you go to Applications, you should be able to see Utilities. Under Utilities, you should be able to see Terminal. What I'll suggest you do is drag it and drop it on your dock so that you always have access to it immediately. But from there, you should be able to click on Terminal. If you are on Windows, what you need to do is go to the Windows search on the bottom left and type CMD. CMD is for command. That's going to take you to the command line or the terminal or the shell, and you should be able to go from there. Sounds good? What questions do we have? Feel free to ask whatever questions you have so I can do my best to respond. All right. So again, for those that are using Mac, you would not, yes, I think you have a question. Fred, go ahead.
Yeah, I just wanted to ask, you said when we get the command line and then in Windows, which there was something you say with Python something to know if it's installed in Windows computer or not.
Very good. So what you need to type for Windows is Python. You give a space, and then you put 2 dashes and type in version.
Okay.
If I do that on my Mac, it's definitely going to say it's an error. Yeah, it doesn't know that. For the Mac, what I need to do is type Python 3. So I'll need everyone to at least give me a heads up. Those that have it pre-installed and those that do not have it pre-installed. Does everybody have it installed yet?
Yeah, I have it installed.
Okay. So everybody has it installed. How about you, Abel? So it looks like everybody should have it installed. For those that don't have it installed, that is totally not a problem. What we'll need to do is just go to Anaconda. When you get to Anaconda, let me go ahead and use my virtual.
I don't have it. I get a message that Python was not found. Wrong with that
Awesome.
argument.
So if Python was not found, what I would encourage you to do is go to Anaconda and either download it or use it in the cloud. I'll encourage you to use it in the cloud. That's fine. If you download it, that's also fine. But let's start by using it in the cloud. Tomorrow, we're going to make sure everybody has it downloaded. I can give you that as your homework to download it. But let everybody go ahead, go on the cloud. I can log in now because I already have an account. Okay. Actually, I'm lying. This is for me to create an account. Instead of me creating an account, I don't want that. I want to log in because I already have an account. So let's go ahead and log in into the Anaconda nucleus. To log in, I'll put my username and my password. It should be straightforward. So to create an account, you're going to put in your username, password. It will send you confirmation email, something like that, and so on. So it definitely takes me to the last part where I was, but I'll go ahead and start a new one altogether. All right, everybody good? So 2 things that I'm going to need from you guys before I proceed. First is for those that do not have Anaconda, or sorry, that do not have Python, you can go ahead and start downloading it. It might take a minute, but also go ahead and sign up on anaconda.com. From there, we're going to be using Anaconda on the cloud, and I'll be able to explain to you all of these when we get back. So that said, let me finish up this slide, and then we have about, I'm behind with time here. So we actually have the next thing that was coming up is our break time. Okay. So our break time is going to be 5 minutes. Actually, I'll give you 10 minutes. I'll give you 10 minutes. And then when we come back, we're going to carry on where we ended. Abel, you have a question, go for it. You might have to unmute your mic. Okay, Abel, you're still muted. We cannot hear you.
All right, sorry about that. Can you hear me now?
Yes, we can hear you now.
I joined the class just some few minutes ago. I wasn't aware of the class. Thank you for giving us this opportunity. Then I think my suggestion would be that you give us you let us know what to download during the break time, so that when you come back we can move forward. What you want us to do.
Very good suggestion. Very, very good. So like I pointed out, what I'll need you to do is go to anaconda.com. Let me go ahead and type that again. Oopsie. Go to anaconda.com, download Anaconda, and also create an account in the cloud. Okay. So for instance, I already have it, so I don't really need to, but that's fine. I'll go ahead and download it. If I click on download, it starts downloading, as you can see here. Whenever it's done downloading, that's totally fine, but go ahead and click on in the cloud so that you can also have it running in the cloud, and you should be able to go from there. Okay, so it's probably going to take about less than 10 minutes to download, and then you install it. But go ahead and also code in the cloud. When you go ahead and create a username and password, it will let you sign in. When you sign in, you should be able to see a page like this. So after the 10 minutes break, when we come back, that's where we're going to carry on from. Sounds good to everyone?
That's good.
Awesome, awesome. So again, let me go ahead and share this link so everyone can have access to Anaconda, and then we'll go from there. In the meantime, 10 minutes break. Let me go ahead and add the 10 minutes timer. I really have to encourage you guys to take your breaks, because you need your brain to rest for a minute before we continue. So in this 10-minute break, I'll go ahead and indulge you with some background music while you're waiting.